The sun hangs low, a pale disk in the vast Siberian sky. The air smells of wet earth and something ancient, like cold stone. Your boots sink into the mud of the riverbank, a slurry of silt and thawing permafrost. It's not rocks you're navigating, but bones, thousands of them. Rib cages the size of small boats surface from the dark water. A tusk, perfectly preserved, curves from the mud like a scythe, its ivory gleam a shock against the grey landscape. This isn't a fossil bed. It's a tomb, a mass grave for an entire species frozen in the moment of its collapse. For 400,000 years, they dominated this world, weathering ice age after ice age, and then, in a geological instant, they were gone. Why? You're standing at the edge of an extinction event, a mystery preserved in ice and bone for 10,000 years. Before we try to read the story written in this frozen earth, let me ask you something. Wherever you are right now, just pause for a moment. Wherever you're listening tonight, a quiet room in Kyoto, a late-night drive through Kansas, a balcony overlooking Cairo, welcome to Sapiens Untold. It's good to have you here. Where are you listening from? And what time is it where you are? Take a moment, settle in, get comfortable, dim the lights if you can. We are a community of curious minds gathered around a digital fire to investigate the silences in our history. We don't have all the answers, but we have better questions. If that sounds like a journey you want to be on, consider hitting that like and subscribe button. It tells us we're on the right track and helps us continue these expeditions into the unknown together. Now, let's return to the riverbank, where the bones of giants are eroding out of time itself. The mystery isn't just that they died, it's why they died so suddenly, and all at once. You are in a cathedral of cold. The air is dry and bites at your skin, thick with the hum of industrial freezers. Here, in a secure laboratory, you stand before a glass case containing not a skeleton, but a body. Her name is Liuba. She is a baby woolly mammoth, only a month old when she died 40,000 years ago. Her skin is intact, a delicate tracery of wrinkles around her closed eyes. The fine reddish hair on her legs is still visible. She is not a fossil, she is a time capsule. This stunning preservation is central to the mystery. Paleontologists have found that her death was sudden. In her stomach, they discovered not just her mother's milk, but the silt and clay that choked her, the signature of a flash flood or a collapsing riverbank, a final, violent moment captured in perfect detail. She was buried so quickly that scavengers never found her. And she is not alone. Across the vast mammoth steppe of Siberia and Alaska, thousands of individuals have been found in similar states of sudden death, their bodies flash-frozen without signs of predation or disease. Carbon dating places their demise in a tight cluster, a catastrophic spike in mortality between 10 and 12,000 years ago. The mystery deepens when we consider their resilience. These were not fragile creatures. Woolly mammoths thrived for 400,000 years, a dynasty that weathered multiple glacial cycles and the warming periods in between. They were perfectly adapted, from their thick, shaggy coats and small ears that minimized heat loss to their ability to survive on the tough grasses of the frozen plains. Their populations numbered in the millions. So, what happened? Why did a species that had mastered survival on an ice age planet suddenly falter and vanish within a geological blink? Liuba's perfectly preserved form doesn't offer a final answer. It just asks a more profound question. What changed in their world so violently that resilience was no longer enough. You crouch low to the ground in what was once a shallow basin on the plains of ancient North America. The wind whips dust across the dry earth. Your fingers trace the outline of something half buried in the sediment. It's not a rock. It's a stone point, fluted and lethally sharp, crafted with an artistry that feels both alien and intimately familiar. This is a Clovis point, and it was found here, among the scattered ribs of a Columbian mammoth. This is a kill site. For decades, the prevailing image was one of human triumph. Small, brilliant bands of hunters spreading across a new continent, felling giants with their sophisticated stone-tipped spears. This is the foundation of the overkill hypothesis. Multiple lines of evidence suggest a provocative correlation. The arrival of Clovis hunters in the Americas around 13,000 years ago coincides almost perfectly with the rapid disappearance of mammoths and other megafauna. The timing is suspicious. At sites across North America, Europe, and Asia, archaeologists have found undeniable proof of interaction. Butchered mammoth bones, ivory tools, and even entire dwellings constructed from mammoth skeletons, a testament to their intensive use as a resource. Computer models have shown that even a modest, sustained hunting pressure on a slow reproducing species like the mammoth could, theoretically, drive them to extinction in a matter of centuries. But competing theories each have strengths and weaknesses, and this one has significant problems. Could small groups of Stone Age hunters truly exterminate millions of mammoths spread across the entire northern hemisphere? In Africa and Asia, humans and megafauna coexisted for tens of thousands of years without such catastrophic extinctions. Why was it different here? Furthermore, in some regions, the mammoths seem to disappear from the fossil record before the first evidence of a significant human presence. The Clovis point in your hand is a tangible link between our ancestors and these lost giants. It proves they were hunted, but it doesn't prove they were hunted to extinction. Correlation, as the saying goes, is not causation. Now, you stand at a geological boundary line etched into the wall of a trench dug in Murray Springs, Arizona. Below your feet, the soil is light tan, rich with the fossilized remains of the Ice Age: mammoth, horse, camel, dire wolf. But then there is a stark, abrupt line. Above it lies a layer of dark, organic-rich sediment a few centimeters thick. Geologists call it the black mat. And within this black mat, there are no mammoth fossils. None at all. They just stop. This boundary, dated consistently to around 12,900 years ago, marks a moment of profound and sudden change. It's here that a third, more controversial theory takes root: the Younger Dryas impact hypothesis. Proponents argue that a fragmented comet or asteroid struck or exploded over the North American ice sheet, triggering continent-wide firestorms and plunging the planet into a sudden, 1,000-year cold snap known as the Younger Dryas. This wasn't gradual climate change. It was a violent climate whiplash. The evidence for this cosmic event is found within layers like the black mat. Researchers have reported discovering microscopic nanodiamonds, magnetic spherules, and elevated levels of platinum, markers consistent with an extraterrestrial impact. These anomalies have been found at dozens of sites across multiple continents, all dating to the same precise geological moment. An impact of this magnitude, the theory goes, could explain the sudden, catastrophic nature of the extinctions far better than the slow pressures of human hunting or gradual warming. But the hypothesis remains fiercely debated. Many scientists argue that the geological markers have alternative explanations and that the evidence for a cosmic impact is inconclusive. Yet the black mat remains. It is a scar in the earth, a line drawn across time. Below it, a world of giants. Above it, a world much like our own, and a profound silence in the fossil record. You are standing on 2 miles of solid ice, under a sky so clear and vast it feels like outer space. The silence of the Greenland ice sheet is absolute, broken only by the whine of the wind and the deep groan of the glacier beneath you. Here, scientists drill down through millennia of accumulated snowfall, pulling up cylinders of ice that are libraries of ancient atmosphere. Your gloved hand rests on a freshly extracted core, its icy surface cold enough to burn. Within its layers, trapped air bubbles hold the precise chemical signature of Earth's climate, year by year, for over 100,000 years. This is where the mainstream scientific view, the climate change hypothesis, finds its strongest voice. The ice cores provide an unambiguous record of a rapid warming at the end of the last ice age. Temperatures surged, fundamentally transforming the Mammoths' world. Pollen trapped in lake sediments tells the same story. The Mammoth steppe, a vast, cold, dry grassland rich in the nutritious grasses and herbs these giants relied upon, vanished. In its place rose dense boreal forests and soggy wetlands, environments utterly unsuitable for a cold-adapted grazing specialist. The logic is compelling. The world changed, and the mammoths, unable to adapt, disappeared with their lost habitat. It's a clean, elegant explanation for a messy extinction. But here, holding this cylinder of ancient time, the simple answer feels incomplete. The ice cores also show that mammoths survived multiple previous warming periods, interglacials just as warm as the one that finally killed them. They had weathered these climate shifts before. Why was this time different? Some scientists argue the speed of the warming was unprecedented, a thermal shock the ecosystem couldn't absorb. Yet even this doesn't quite fit, because in some parts of Siberia that retained steppe-like conditions, the mammoths vanished anyway. The ice tells a clear story of climate change, but it doesn't explain why this one final change proved fatal. You lean closer to the ice core, now laid out on a lighted table in a sub-zero research facility. The paleoclimatologist beside you points to a specific layer with a gloved finger. To your eye, it looks no different from the ice above or below it. But the mass spectrometer tells a different story. Here, she says, her voice quiet with a kind of reverence. This is the Younger Dryas boundary, 12,135 years ago. The data appears on a nearby monitor, a graph showing a dramatic spike in a single element, platinum, an element rare on Earth's surface but abundant in asteroids and comets. This is the evidence that gives the cosmic impact theory its scientific weight. That platinum spike, found in this Greenland ice core, has also been detected in sediment layers of the exact same age on nearly every continent on Earth. It is a global signature, a thin dusting of extraterrestrial material that coated the planet in a single moment. And that moment coincides precisely with the onset of the Younger Dryas, the 1,000-year deep freeze that disrupted the end Pleistocene warming trend. The ice core doesn't just show a platinum anomaly. It records the cataclysmic climate shift that followed. Isotope readings show that average temperatures in the northern hemisphere plummeted by as much as 8 degrees Celsius in the span of a decade, a change so abrupt it defies normal climatic processes. This wasn't a gentle cooling, It was as if a planetary switch was thrown. The sudden freeze, followed by an equally rapid warming a millennium later, would have been a devastating 1-2 punch to ecosystems and the megafauna that depended on them. The platinum spike doesn't prove an impact killed the mammoths, but it suggests a violent external trigger for the very climate chaos that presided over their extinction. It offers a potential cause for the catastrophe, not just a description of its aftermath. You are no longer in the frozen north, but kneeling in the dry heat of the Atacama Desert in Chile. The air shimmers, and the ground cracks beneath your hands. You run your fingers over a familiar feature in the exposed rock strata, a thin, dark line, barely the width of your thumbnail. It is the black mat, the same geological marker you saw in Arizona, thousands of miles away. It has been found in Syria, in Belgium, across North America. It is a planetary scar tissue, a consistent forensic layer marking a moment of global trauma precisely 12,900 years ago. It's this ubiquitous layer that both supports and complicates the cosmic impact hypothesis. How could a single impact in North America leave a consistent chemical and physical signature across the entire globe? Critics of the theory correctly point out that this would require either a truly colossal impact, far larger than any crater we've found from that period, or a series of coordinated smaller impacts across the planet, a scenario that seems statistically improbable. This is the hypothesis's greatest weakness, the lack of a definitive smoking gun, a crater of the right age and size. Yet the layer persists, a silent, stubborn fact. Inside this thin black line, geologists have identified not just platinum and nanodiamonds, but melted glass spherules and charcoal, evidence of continent-spanning wildfires that raged at temperatures hot enough to fuse sand. Something burned a vast portion of the planet's biomass at the exact moment the climate plunged into chaos. The evidence preserved in this thin line speaks to a catastrophe of a scale that is difficult to comprehend. The Younger Dryas impact remains a controversial outlier in the scientific community, but the physical evidence it seeks to explain, this dark seam running through the planet's recent history, is an undeniable and deeply unsettling part of the geological record. It is a boundary line between two different worlds. You're standing on the Hiawatha Glacier in northwest Greenland. It is a desolate, hypnotic landscape of white. Nothing moves, nothing grows, and yet beneath your feet, hidden under a half-mile of ice, is perhaps the most significant clue in the entire cosmic impact debate. You look down at the screen of a ground-penetrating radar unit. On it, an image is slowly resolving, built from radio waves bounced off the bedrock far below. It is the unmistakable shape of a circle, a perfect 19-mile-wide circular depression. This is the Hiawatha crater, discovered in 2018. It is the first, and so far only, large crater ever found beneath the Greenland ice sheet, and it has re-energized the impact hypothesis. Its size is consistent with an object large enough to have caused significant, continent-wide climate disruption. Initial analyses of the rock and ice surrounding the feature suggest it is geologically young, possibly less than 100,000 years old. It is a tantalizing piece of evidence, a potential smoking gun where none existed before. But science is a slow, cautious process. New discoveries continue to revise our understanding, and the crater is no exception. More recent studies analyzing argon isotopes from melted rock at the crater's base have dated the impact not to 13,000 years ago, but to 58 million years ago. If this older date is correct, the Hiawatha crater cannot be the cause of the Younger Dryas climate event. The scientific jury is still out. Dating a feature buried under so much ice is incredibly complex, and different methods are yielding conflicting results. The crater exists. Its age, and therefore its relevance to the mammoth extinction, remains one of the most active areas of debate in geology today. It is a ghost image on a radar screen, a circular shadow that deepens the mystery rather than resolving it. You are inside a clean room, surrounded by the quiet hum of sequencers and servers. The air smells sterile, like ozone and electronics. In your hand, you hold a small vial containing a clear liquid. It seems like nothing, but it holds the ghost of an entire species. This is a solution containing fragments of DNA, painstakingly extracted from the 40,000-year-old femur of a Siberian woolly mammoth. Here, in the realm of ancient genetics, the search for a single culprit, climate, humans, or impact, gives way to a more complex and perhaps more accurate story. The emerging scientific consensus is that there was no single cause. Instead, the mammoths fell victim to a devastating synergy of pressures, a perfect storm of environmental and biological stress. This is the multiple stressor hypothesis. Genetic studies of mammoth DNA, like the sample in your hand, reveal a crucial part of this narrative. By sequencing genomes from different times and locations, scientists have found that mammoth populations were already in trouble long before they vanished. Their genetic diversity was declining, a classic sign of a species under stress, likely from shrinking habitats and fragmented populations. Small, isolated herds became vulnerable to inbreeding, further weakening their resilience. Then came the final blows. A rapidly changing climate pushed their food sources to the brink. A new, hyper-efficient predator, us, began hunting the weakened herds. A possible cosmic event may have delivered a catastrophic shock to an already fragile system. Computer models that incorporate these multiple factors, climate, hunting, and habitat loss, do a far better job of replicating the observed extinction pattern than any single cause theory. The truth, it seems, lies not in finding a lone killer, but in understanding how a combination of pressures, each one survivable on its own, could cascade into an inescapable vortex of extinction. It's a sobering lesson, one with profound echoes in the challenges facing large animals in our own time. You're looking at a screen displaying an image magnified millions of times. It's a transmission electron microscope, and the subject of its intense focus is a grain of dust from the Younger Dryas boundary layer. On the screen, you see them, impossibly small crystalline structures, nanodiamonds, specifically a form called lonsdaleite, which is hexagonal in shape. On Earth, this structure is formed only one way, the shock and pressure of a high-velocity impact, like a meteorite strike. They are microscopic evidence of a moment of unimaginable violence. These tiny diamonds are a key pillar of the impact hypothesis and a source of intense scientific debate. They have been reported in the 12,900-year-old boundary layer at sites across the world. Their presence, proponents argue, is a definitive fingerprint of a cosmic event, an impactor striking the carbon-rich surface of the Earth. Either the ice sheet or the forest below would create the perfect conditions, immense heat and pressure, to forge these microscopic gems from terrestrial carbon. They are, in essence, the fossilized remnants of a shockwave. However, like every piece of this puzzle, the nanodiamond evidence is contested. Some research has failed to replicate the original findings, with scientists questioning whether the samples were contaminated or if the structures were misidentified. Other studies propose alternative, non-impact mechanisms for their formation, such as cosmic dust accumulating over time or even intense wildfires. The debate is a perfect example of the scientific process in action: claim, counterclaim, and a slow, methodical search for reproducible results. Yet the question these tiny crystals pose is profound. What event, 12 and 900 years ago, was powerful enough to forge diamonds in the dirt? And could that same event have brought an end to the age of mammoths? The answer is still being argued, one microscopic crystal at a time. You're in a small boat on the East Siberian Sea, the grey water choppy under a grey sky. The air is cold, heavy with the smell of salt and diesel. 70 miles to the north, shrouded in mist, lies Wrangel Island. It is a place that fundamentally challenges every simple explanation for the mammoth's demise. Because here, on this remote Arctic outpost, the woolly mammoths did not die out 10,000 years ago. They survived. For 6,000 years after their mainland cousins vanished, a small, isolated population of mammoths lived on Wrangel Island. They were contemporaries of the pyramid builders in Egypt, of the first dynasties in China. Their survival is a living experiment that complicates the entire extinction event. If the global climate change at the end of the Ice Age was so catastrophic that it wiped out millions of mammoths across 3 continents, how did this small population endure for 6 additional millennia in the high Arctic, a region that should have been exquisitely sensitive to warming? Their existence proves that mammoths could persist in refugia, that the changing climate alone was not a universal death sentence. The end for the Wrangel Island mammoths came around 4,000 years ago, and their extinction is its own miniature mystery. Genetic analysis of their remains shows a population in deep trouble. Extreme inbreeding had led to a genetic meltdown, leaving them with harmful mutations that may have affected their metabolism and sense of smell. There is also tantalizing, though not yet conclusive, evidence of the first human arrival on the island around the time the last mammoths disappeared. Did our ancestors deliver the final blow to a population already teetering on the genetic brink? Whatever the cause, Wrangel Island serves as a crucial control group. It demonstrates the inadequacy of any single theory and forces us to consider a more nuanced, localized picture of extinction. You are in a darkened room, illuminated only by the glow of a massive screen. On it, a detailed sonar map of the seafloor between Siberia and Alaska resolves into focus. You can see the ghost of a landscape, river channels, rolling hills, and vast flat plains. This is Beringia, the drowned world that once connected Asia and North America. It was the heartland of the Mammoth steppe, and for most of the Ice Age, it was dry land. The story of the mammoth extinction is inseparable from the story of sea level rise. As the great ice sheets melted at the end of the Pleistocene, they released unfathomable volumes of water into the oceans. Global sea levels rose by nearly 400 feet. This wasn't a gradual process. It happened in catastrophic pulses. At certain points, like Meltwater Pulse 1A, around 4,500 years ago, sea levels may have risen as much as a foot per decade. For the mammoths, this meant their world was literally shrinking beneath their feet. Vast coastal plains, the richest parts of their grassland habitat, were consumed by the advancing ocean. This rapid loss of prime territory would have acted as a powerful amplifier for every other stressor. It would have concentrated populations into smaller and smaller inland areas, increasing competition for dwindling resources. It would have made them more vulnerable to human hunters who now found their prey conveniently corralled. It would have fragmented large, interconnected populations, creating isolated pockets like Wrangel Island that were susceptible to genetic decline. The drowning of these landscapes is a critical, often overlooked part of the extinction puzzle. We search for clues on the land that remains, but a significant part of the evidence, and perhaps the answer itself, now lies hundreds of feet beneath the waves, in a world that belonged to the mammoths, now lost to time. The first light of dawn spills across the Anatolian plain in southeastern Turkey. The air is cool and smells of dust and wild thyme. Before you, arranged in great circles, stand monolithic limestone pillars, T-shaped and towering up to 18 feet tall. They feel impossibly ancient. This is Göbekli Tepe, and it forces us to reconsider the human side of the mammoth extinction story. Orthodox archaeology dates the construction of this site to around 9,600 BCE, nearly 12,000 years ago. This makes it the oldest known megalithic temple in the world, built 6,000 years before Stonehenge. And here is the crucial point. It was built immediately after the Younger Dryas cold event ended and the world began its final rapid warming. The people who carved these stones were the direct descendants of the survivors of that cataclysm. They were hunter-gatherers living in a world that had been shattered and was now being remade. The mammoths were gone. The great herds of the Ice Age were a fading memory, and in their place, humanity began to build. Some researchers see a direct link. Carved onto one of the most prominent pillars at Göbekli Tepe is a vulture flanked by other animals in a scene that has been interpreted as a celestial map. The arrangement of the animals, some argue, precisely mirrors the constellations as they would have appeared in the sky around 10,150 BCE, the very time of the proposed Younger Dryas impact. Is this a coincidence, or is it a memorial? A story, carved in stone by the survivors, of a day when the sky fell, an event that wiped the world clean and ended the age of giants. We look at Göbekli Tepe and see the birth of civilization. But perhaps what we are really seeing is a message from the survivors of the world's last great extinction. You place your hand on one of the great pillars of Göbekli Tepe. The limestone is cool, weathered by 12,000 years of sun and wind. Your fingers trace the deep grooves of a carving, not a mammoth or a bison, but a scorpion. Below it, a headless man. Around you, the entire complex is a zoo of stone animals, foxes, boars, cranes, snakes. But it's the arrangement that is haunting. Proponents of a controversial theory suggest this isn't just art, it's a sophisticated astronomical record. Göbekli Tepe, they argue, was a pre-agricultural observatory built by people with a profound and urgent understanding of the sky. The central pillars of each stone circle seem to align to specific points on the horizon, marking solstices and equinoxes. More startlingly, the animal symbols themselves may represent constellations. The vulture, or Cygnus, the scorpion, or Scorpius. The specific arrangement on Pillar 43, the vulture stone, is claimed to be a date stamp, a depiction of the sky at the very moment of the Younger Dryas impact, recording a cataclysm caused by fragments of a disintegrating comet. This interpretation is far from mainstream. Most archaeologists see Göbekli Tepe as a ritual center, a gathering place for hunter-gatherer cults. They argue that attributing advanced astronomical knowledge to pre-literate people is an overreach, yet the alignments are there. and the timing is undeniable. This monumental effort of engineering and artistry began just as the Ice Age world was ending. Why would a society of foragers struggling to survive in a world of unprecedented climate chaos devote generations of labor to building a massive, astronomically aligned temple? Perhaps the answer is simple. Perhaps they built it because they had just witnessed something terrifying in the heavens, and they wanted to ensure that no one would ever forget it. They were creating a library of memory, written in the universal language of stars and stone. You're standing before Pillar 43, the Vulture Stone. It's late afternoon, and the low sun casts the carvings in sharp relief. Your eye is drawn to the handbag-like symbols at the top, objects that appear in carvings thousands of years later in Sumeria and Mesoamerica. But it's the main panel that holds the alleged cosmic code. At the center is the vulture, its wing outstretched. A small, headless human figure lies below it. Surrounding them are other creatures, a scorpion, a wading bird, a serpent. A small circle, like a sun or moon, floats above the vulture's wing. To an archaeologist, this is a complex symbolic scene, perhaps depicting a funerary rite or a shamanic journey. But to an archaeo-astronomer, it's a star chart. Using sophisticated software that can rewind the night sky, they demonstrate that the arrangement of these animal symbols is a strikingly accurate map of the constellations surrounding the summer solstice sunrise as it appeared from this exact spot in 10,150 BCE. The scorpion is Scorpius, the wading bird is Sagittarius, the vulture is the brightest star in the constellation Cygnus. The headless man, they argue, symbolizes the death of an age. And what was happening in 10,150 BCE? According to the impact hypothesis, that is precisely when the Earth was passing through the densest part of the torrid meteor stream, the debris field of a giant fragmenting comet. The vulture stone, in this interpretation, is a snapshot of the sky at the moment of disaster. A snapshot that records a meteor shower so intense it triggered global catastrophe and ended the Pleistocene. It is a radical theory, one that pushes the boundaries of what we believe hunter-gatherers were capable of. But the pillar stands, silent and indifferent to our debates. Is it merely a stone canvas of myth and ritual? Or is it the oldest warning in human history? You step back from the vulture stone, letting your eyes adjust to the vastness of the Turkish sky. The astronomical interpretation of Göbekli Tepe hinges on a concept both simple and profound: precession. Because the Earth wobbles on its axis like a spinning top over a 26,000-year cycle, the stars do not keep fixed positions in the night sky. Constellations slowly drift. This means that a stellar alignment that was perfect 13,000 years ago is no longer visible today. The builders of this temple, if the theory holds, were aligning their sacred architecture to a ghost in the heavens, a specific celestial moment that has long since passed. To test this, you can't just look up at the night sky. You have to reconstruct it. Archaeologists and engineers have used satellite data and complex software to map the precise orientation of every pillar and enclosure at Göbekli Tepe. When they input the coordinates and run a simulation of the precessional cycle backwards in time, a stunning pattern emerges. Around 9600 BCE, when the site was first built, the central pillars of the main enclosures framed the rising of the star Sirius, the brightest in the sky. As precession continued, the builders deliberately buried the old enclosures and built new ones, realigning them to keep pace with the shifting heavens. This suggests an obsession with the sky that lasted for over 1,000 years. It implies not just a single moment of observation, but a continuous, multi-generational project of astronomical monitoring. This is where the story connects back to the Mammoths' world. If the people who lived through the Younger Dryas believed a cosmic event was the cause, it would make sense that they would become the most dedicated sky watchers in history, tracking the constellations and meteor showers with a focus born of trauma, hoping to predict and prevent a recurrence. Göbekli Tepe may not be a memorial to a single impact, but a perpetual observatory built by the survivors to keep watch on the sky that had once tried to kill them. You stand on the rim of Dry Falls Coulee in eastern Washington state. The scale is almost impossible to process. You are looking at what was, for a brief time, the largest waterfall on Earth. It is 3.5 miles wide, 400 feet high, and today it is completely dry. The scarred basalt cliffs below you were carved not by millennia of gentle erosion, but by a cataclysmic flood of almost unimaginable power. This landscape, known as the channeled scablands, is a testament to the violent forces that reshaped North America at the end of the Ice Age. For decades, geologists believed these features were formed by the repeated collapse of an ice dam holding back the massive glacial Lake Missoula. But the timing of the last great flood pulses aligns provocatively with the Younger Dryas boundary. Proponents of the impact hypothesis offer a different trigger. An impact on the Laurentide ice sheet, they argue, would have instantly liquefied vast quantities of ice, unleashing a continent-spanning deluge that dwarfed the Missoula floods. The heat of the impact and the shock wave it generated would not have melted the ice sheet slowly from the edges, but flash melted it from the top down. This theory helps explain a number of puzzling features across the continent, from the strange orientation of the Carolina bays along the east coast to the vast fields of boulders dropped seemingly at random across the Midwest. A mega flood of this scale, originating from the ice sheet itself, would have been a near-extinction level event for anything living in its path. It would have destroyed ecosystems, scoured landscapes down to bedrock, and dumped trillions of tons of cold, fresh water into the Atlantic, potentially disrupting the ocean currents that regulate global climate. It is a terrifying vision of the past. The scars in the earth here are undeniable. The question that remains is what precisely unleashed the water. You are in a supercomputing lab, surrounded by the cool, clean air and white noise of cooling fans. On the screen before you, a digital model of North America, 13,000 years in the past, is running a simulation. A virtual comet fragment, several kilometers wide, strikes the 2-mile-thick Laurentide ice sheet over what is now Michigan. The initial flash of energy vaporizes cubic miles of ice. A fraction of a second later, a shockwave propagates outward, fracturing the glacier and unleashing a torrent of meltwater. This is how scientists investigate a past they cannot see directly, through modeling. By inputting the known geological data, the topography of the pre-flood landscape, the estimated volume of the ice sheet, the physics of a hypervelocity impact, they can reconstruct the consequences. The simulation shows a wall of water, hundreds of feet high, blasting south and west. It carves the channeled scablands in a matter of days. It dumps enough fresh water into the North Atlantic to shut down the ocean's heat-conveying currents, plunging the world into the Younger Dryas cold. The simulation is hypnotic, a vision of planetary violence. But it is just that, a simulation. It is a powerful tool for testing a hypothesis, but it is not direct evidence. The model's output is only as good as the assumptions programmed into it. Mainstream geology still largely favors the glacial Lake Missoula hypothesis, arguing that the evidence on the ground is better explained by a series of smaller, though still enormous, floods from a terrestrial source. The debate highlights the limits of our ability to reconstruct ancient events with certainty. The Earth bears the scars of a great flood. The computer models show us one plausible way it could have happened, but the ultimate trigger, a collapsing ice dam or a falling comet, remains a profound and unsettled question. You're flying in a small plane over the lush, rolling hills of southern Ohio. Below, etched into the landscape, is a form so vast you can only appreciate it from the air. It is a serpent, over 300 feet long, its earthen body undulating across the ridge of a high plateau, the Great Serpent Mound. For years, archaeologists attributed this effigy to the Adena, or Fort Ancient cultures, dating it to around 1000 AD. But here, the story takes a familiar turn. Recent, more rigorous carbon dating of charcoal samples taken from deep within the mound's undisturbed layers tells a different story. It suggests the serpent is much, much older. In 2014, a team of researchers presented evidence that the original construction of the mound dates not to 1000 AD, but to 300 BCE. But even more startling, they found evidence of an even earlier construction phase and possible repairs that align with a specific moment in time, 10,700 BCE, the Younger Dryas boundary, the same time that Göbekli Tepe was being built on the other side of the world. The serpent's head is aligned to the summer solstice sunset. But researchers investigating celestial connections found another, more specific alignment. The curves in the serpent's body appear to mirror the constellation Draco, with the pole star Thuban at its center, as it would have appeared in the sky during the Younger Dryas. And at the serpent's head, an oval shape it appears to be swallowing, there is a geographical anomaly, a crater-like structure formed by a meteorite impact hundreds of millions of years ago. A serpent, aligned to the stars of a traumatic celestial moment, appearing to consume a symbol of cosmic impact. Is this another coincidence? Or does the serpent mound represent a uniquely American memory of the same event that may have been recorded in stone in Turkey? An echo of a global catastrophe that ended the world of the Mammoths, preserved in the sacred earthworks of their human contemporaries. You walk the length of the serpent mound, from its coiled tail to its open jaws. The sun is setting, and the effigy's head points directly toward the disappearing light, a perfect alignment with the summer solstice. This precision feels deliberate, purposeful, but what was its purpose? If this earthwork is indeed a memorial to a cosmic event, it speaks to a level of trauma and cultural memory that is difficult for us to imagine. Consider the symbolism. Serpents, in mythologies across the globe, are often associated with chaos, destruction, and the underworld. Comets, with their long, glowing tails, have been seen as serpents in the sky for millennia. The builders of this mound, living in the immediate aftermath of the Younger Dryas, would have been survivors. They would have inherited stories of a world torn apart by fire and flood, of skies filled with terrifying apparitions, of the great beasts that once roamed the land suddenly vanishing. Building a massive effigy of a celestial serpent wouldn't have been an abstract artistic gesture. It would have been an act of profound ritual significance, an attempt to comprehend, appease, or ward off the terrifying powers of the cosmos. This interpretation, of course, is highly speculative and not accepted by mainstream archaeology. The older dating of the mound is itself a recent and debated development, but it provides a compelling, unified narrative for some of our planet's most enigmatic ancient sites. From the pillars of Göbekli Tepe to the Serpent Mound of Ohio, it suggests a shared human response to a global catastrophe, a catastrophe that may have cleared the stage of its Ice Age megafauna and, in a strange, brutal way, paved the way for the rise of our own civilization. The serpent in the earth remains silent, its ultimate meaning still a mystery, but its alignment to the heavens is a fact we can measure, a clue that points to a lost chapter in the story of our planet and ourselves. You are in the hushed, climate-controlled archives of a university library, surrounded by the scent of old paper and leather. You carefully open a book, its pages brittle with age. It is a collection of indigenous myths from the Amazon basin. You read a story of a time when the sky fell, of a great fire that burned the world, followed by a torrential flood that drowned the ashes. The details are fantastical, talking animals, angry gods, but the core elements are strangely familiar. Fire, flood, a world destroyed and remade. This is not a unique story. Flood myths are a human universal. They are found in over 500 cultures on every inhabited continent, from the Epic of Gilgamesh in ancient Mesopotamia to the stories of the Anishinaabe people of North America. Traditionally, these have been dismissed by scholars as local fables, cautionary tales about river floods or tsunamis, but their sheer ubiquity and the startling similarity of their core structure has led some researchers to ask a radical question. What if these are not myths at all, but memories? Memories of a single, global event passed down through countless generations. The details often align with the physical evidence of the Younger Dryas period with an eerie precision. Many stories speak not just of a flood, but of a preceding period of cosmic chaos. Stars falling from the sky, the sun and moon disappearing. A great serpent or dragon in the heavens. Could these be the fragmented, mythologized recollections of the torrid meteor stream and a subsequent cometary impact? It's a deeply controversial idea, one that pushes the boundaries of scientific inquiry into the realm of mythology. Oral traditions are not hard data, but the possibility is haunting. What if the answer to what happened at the end of the Ice Age isn't just buried in the ice cores and geological strata, but is also hidden in plain sight in the oldest stories we have ever told? You sit by a fire in the high desert of Arizona, the flames casting flickering shadows against the canyon walls. An elder of the Hopi people is speaking, his voice soft but resonant. He is not talking about geology or archaeology. He is talking about the first world, Tokpela. It was a world of perfect balance, he says, but humanity lost its way. So the Creator destroyed it with a great fire that rained down from the sky. The few who were righteous were hidden underground, and when they emerged, the world had been remade. The stars were in different places. This is not an academic lecture. It is a living memory, a piece of cultural DNA passed down for uncounted generations. And it is not unique. The Choctaw people of the American Southeast tell of a time of darkness, a great fire from the north that was so intense it melted the land. The Algonquin speak of a sky fire that fell to earth, followed by a great flood. The parallels to the geological evidence of the Younger Dryas, a northern impact, continent-spanning firestorms, catastrophic meltwater floods, are difficult to ignore. Of course, these are not scientific accounts. They are sacred stories, rich with metaphor and meaning that go far beyond a simple description of events. To treat them as literal history would be a profound disservice to the cultures that have preserved them. Yet, to dismiss them entirely may be to ignore a vital source of information. The human mind is a pattern-seeking instrument. Traumatic events on a planetary scale would have been the single most significant experience of the people who lived through them. It is not just plausible, but likely, that these experiences would be encoded into their deepest myths, their most sacred stories. The elders speak of fire and water, of a world that ended. Perhaps it is time we learned to listen, not just with the tools of science, but with the humility to hear the echoes of a deep and ancient human memory. You are standing on the Bolivian Altiplano, 13,000 feet above sea level. The air is painfully thin, and the sun is blindingly intense. Around you lies a scene of inexplicable chaos and impossible precision. Massive 100-ton blocks of andesite and red sandstone are scattered like a child's toys. This is Puma Punku, and it is a profound architectural mystery. You run your hand over one of the broken H-blocks, its surface perfectly smooth. The lines are ruler straight, the right angles flawless. You examine a series of drill holes, each one evenly spaced and uniformly bored into one of the hardest stones on Earth. Orthodox archaeology attributes this site to the Tiwanaku culture around 500 AD. The problem is, the Tiwanaku had no writing, no wheel, and only bronze tools. How did they achieve this level of stonework? A precision that challenges even modern machine capabilities. Local Aymara and Quechua traditions tell a different story. They say the site was not built by their ancestors, but by a race of primeval giants in a single night, before the sun was in the sky. And they say it was destroyed not by time or war, but by a cataclysmic flood that swept across the Altiplano. Geologists have found evidence that corroborates this legend, a thick layer of flood sediment covering the entire region, containing the jumbled, broken stones of Puma Punku. Some researchers have even suggested that the site is far older than its official dating, placing its construction before the end of the last ice age. What does this have to do with the mammoths? Puma Punku, like Gobekli Tepe and the Serpent Mound, seems to be a piece of a larger puzzle. It is another site that speaks of anomalous ancient technology destroyed by a great flood with a timeline that is deeply contested. Could it be another fingerprint of a lost pre-cataclysm civilization, one that lived and built in the world of the mammoths and was all but wiped from the face of the earth by the same event that ended the Ice Age? You walk through the ruins of Puma Punku, your boots crunching on the gravelly soil. It is not just the precision of the stonework that is baffling, but the state of the site itself. 100-ton blocks of andesite lie toppled and fractured. The entire complex looks like it was hit by a colossal explosion. It is a scene of utter devastation, and this is where the local legends and the geological evidence meet. The Aymara people say the creator god Viracocha destroyed the site with a great flood because the giants who built it had forgotten him. Geologists, examining the thick layers of sediment that encase the ruins, have found evidence of a massive, chaotic flood event. The stones of Puma Punku are not just broken, they are mixed in with layers of silt, sand, and human remains in a way that suggests a powerful, turbulent wall of water. Some researchers have pointed to the nearby Lake Titicaca, suggesting a catastrophic landslide or seismic event could have caused a localized mega-tsunami. But others, looking at the scale of the sediment layer, which covers a vast area of the Altiplano, argue for a much larger event. This brings us back to the end of the last ice age. Could the cataclysmic meltwater pulses that accompanied the warming of the planet, and perhaps a cometary impact, have had devastating consequences even here, 2.5 miles above sea level? A sudden shift in the Earth's crust from the removal of the immense weight of the ice sheets known as isostatic rebound could have triggered massive earthquakes and volcanic eruptions around the globe. The destruction of Pumapunku may not be a separate mystery, but another data point in a global pattern of catastrophe. The ruins themselves are like a photograph, a single frame capturing the moment that a highly advanced culture was flash frozen in time, its impossible achievements shattered and buried by mud. You are in Paris, but your mind is thousands of miles and thousands of years away. You stand in a quiet, circular room in the Louvre Museum, looking up at a magnificent bas-relief ceiling panel taken from the Temple of Hathor in Dendera, Egypt. It is the Dendera Zodiac, a stunningly detailed map of the heavens. Mainstream Egyptology dates its creation to around 50 BCE, during the late Ptolemaic period. It shows the familiar constellations of the zodiac, along with planets and celestial events. But like so much of our ancient past, its true age and meaning are subjects of intense debate. The zodiac seems to depict the sky at a specific moment. The arrangement of the planets and the orientation of the constellations in relation to the solstices and equinoxes acts as a kind of celestial clock. Several researchers analyzing the chart through the lens of precession have argued that it doesn't show the sky of 50 BCE at all. Instead, they claim it depicts the heavens as they appeared much earlier. Some interpretations place the date as far back as 10,150 BCE, once again the time of the Younger Dryas event. This is a profoundly radical claim. It implies that the ancient Egyptians who built the Dendera temple were heirs to a much older astronomical knowledge, a legacy passed down from a civilization that existed deep in the Ice Age. It suggests they were deliberately memorializing a specific ancient moment in time, the first time, or Zep Tepi, as they called it, a mythical golden age when the gods walked the earth, an age that ended in a cataclysm of fire and flood. Is it possible? Could the Dendera zodiac, like the vulture stone at Göbekli Tepe, be another echo of the catastrophe that ended the Pleistocene? The scientific consensus says no, but the anomaly persists. The sky carved in stone above you seems to be telling a story, one far older than the temple that housed it. It hints at a cycle of world ages, of creation and destruction, a concept central to ancient Egyptian thought and a chilling parallel to the geological realities of our planet's turbulent past. You step back from the Dendera zodiac and the museum room feels small, the air still. The idea that ancient cultures were not just observers, but inheritors of a deep astronomical knowledge is profoundly unsettling to our modern sense of progress. It suggests that history may not be a simple linear march forward, but a series of cycles, of rises and falls. This concept of cyclical time is not a modern invention. It is central to many ancient worldviews. The Hindu Vedas describe yugas, vast ages of spiritual ascent and decline. The Aztecs and Mayans believed in a succession of suns, or world epochs, each ending in cataclysm. Plato wrote of a great flood that destroyed a high civilization, Atlantis, 9,000 years before his time, a date that places this mythical destruction squarely in the aftermath of the Younger Dryas. Are these all just coincidences, the independent inventions of unconnected cultures? Or are they, like the flood myths, echoes of a shared memory? The science of precession gives this old idea a new astronomical backbone. The 26,000-year wobble of the Earth's axis provides a real, measurable cosmic clock, a great year, against which the rise and fall of civilizations could be charted. The builders of Göbekli Tepe, the architects of the Serpent Mound, the keepers of the knowledge that may have been encoded at Dendera, all seem to have been profoundly aware of this grand cycle. This doesn't prove that a lost civilization was destroyed alongside the mammoths, but it creates a framework for understanding how such a memory could have been preserved, not in written texts, which decay, but in stone, in myth, and in the meticulous observation of the one thing that never changes, the slow, predictable dance of the stars. It suggests that the survivors of the last cataclysm may have left us more than just fragmented bones and mysterious ruins. They may have left us a warning, a message about the cyclical nature of time and the fragility of our place in the cosmos. You are standing on the wind-swept Salisbury Plain in England, the silhouette of Stonehenge dark against a bruised purple sky. You reach out and touch the sarsen stone, its surface rough and cold, covered in lichen that glows green in the fading light. This circle of stones, built 5,000 years ago, is a newcomer compared to Göbekli Tepe, yet it shares a common language, a language of stone, of sunlight, of celestial alignment. You recall the pillars at Göbekli Tepe, the T-shaped monoliths covered in animal carvings. You think of the H-blocks at Puma Punku, with their impossible, machine-like precision. You remember the handbag symbol on the vulture stone, a motif that reappears thousands of years later in the hands of the Sumerian Anunnaki and the Mesoamerican god Quetzalcoatl. A pattern begins to emerge. Across continents and millennia, megalithic sites share a cluster of strange, specific characteristics. Massive, multi-ton stones quarried and transported over great distances, complex astronomical alignments to solstices, equinoxes, and specific stars, and a recurring, shared symbolic vocabulary. Mainstream archaeology explains these similarities as convergent evolution, different cultures facing similar challenges, independently arriving at similar solutions. But is it plausible that societies as distant as Neolithic Turkey, pre-Incan Bolivia, and ancient Egypt would all independently develop the same obsession with precessional astronomy, the same megalithic building techniques, the same esoteric symbols? An alternative, more controversial explanation is diffusion. The idea that these sites are not independent inventions, but the scattered fingerprints of a single ancestral tradition, a global seafaring culture that existed before the end of the last ice age, a culture that possessed a sophisticated knowledge of astronomy and engineering, a culture that was shattered by the Younger Dryas cataclysm, but whose survivors, the seven sages, the bringers of knowledge who appear in so many ancient myths, traveled the world, sharing the fragments of their lost knowledge. This is not a proven theory. It is a grand, speculative tapestry woven from threads of myth, geology, and architectural anomaly. But it offers a potential answer to one of the deepest mysteries of our past. Why the first stirrings of civilization all around the world seem to speak with one voice. You are looking at a map, but not a political one. It's a bathymetric chart showing the topography of the ocean floor. You trace the continental shelves, the pale blue shallows that fringe the land masses. During the last ice age, when sea levels were 400 feet lower, all of this was dry land, vast coastal plains, archipelagos and isthmuses that are now submerged. This is where a lost maritime civilization would have lived, and this is why direct evidence of its existence is so hard to find. Our current model of human history is profoundly land-centric. We look for the origins of civilization in fertile river valleys like Mesopotamia and the Nile. But what if that's only half the story? What if there was another, older cradle of civilization, located on the coastlines that vanished beneath the waves? The few clues we have are tantalizing. In India, the submerged ruins of a massive city, now called the Gulf of Cambay site, have been found in 120 feet of water and carbon dated to 9,500 years ago, thousands of years before the accepted start of urbanism in the region. Off the coast of Japan, the Yonaguni Monument, a massive terraced structure that appears to be carved from bedrock, lies beneath the waves, its origins fiercely debated. These underwater anomalies are just whispers, fragmented clues to a lost world. But they align with the hypothesis of a global, seafaring culture of master astronomers and builders. Such a culture would have been devastated by the rapid sea level rise and coastal flooding that accompanied the end of the Ice Age. Their cities and monuments would have been inundated, their knowledge scattered, their populations decimated. The survivors, pushed inland, would have become refugees, carrying with them only the memory of their former glory, a memory that would eventually curdle into the myths of a golden age lost to a great flood. It's a grand, unifying theory that attempts to connect the Mammoth extinction, the Younger Dryas climate event, and the sudden, explosive rise of civilization. But until we can properly explore these drowned coastlines, it will remain just that, a ghost story, haunting the edges of our known history. You're standing at the base of the Great Sphinx at Giza. The monument is so familiar it has become a cliché. But look closer. Run your hand along the limestone wall of the enclosure, the bedrock from which the Sphinx was carved. Your fingers trace a series of deep vertical fissures running from top to bottom. Mainstream Egyptology attributes this erosion to wind and sand. But geologists see something different. They see the unmistakable signature of water. This is the core of the Sphinx water erosion hypothesis, a theory that, if true, shatters the conventional timeline of civilization. The Giza Plateau is a desert. It hasn't seen enough rainfall to cause this kind of deep, precipitation-based weathering for thousands of years. The last time this region experienced a wet, rainy climate was the period between 7,000 and 9,000 BCE. This suggests the Sphinx itself, or at least the initial carving of its enclosure from the bedrock, must be thousands of years older than the pharaohs it is said to represent. It would make it a product of the same mysterious epoch as Göbekli Tepe. This is where the story returns to the Mammoth's end. The period of intense rainfall that carved these fissures into the limestone corresponds to the final chaotic centuries of the Ice Age melt. The world was in flux. Ecosystems were collapsing and reforming. Humans were adapting to a planet radically transformed. If a sophisticated culture was carving monuments like the Sphinx in Africa at the same time hunter-gatherers were building astronomical temples in Turkey, it paints a picture of the post-cataclysm world that is far more complex than we have imagined. It suggests the survivors of the Younger Dryas event were not just scattered bands of foragers, but included groups who retained a high degree of knowledge and organizational skill. The Sphinx may not just be a monument to a pharaoh, but a silent witness, a survivor from a world before our own. its eroded flanks a testament to the rain that fell at the end of the age of ice. You leave the Giza Plateau as the sun sets, casting the pyramids in long, geometric shadows. The air grows cool. You are left with a disquieting thought. If there was a sophisticated human civilization present during the last ice age, one that coexisted with the mammoths and mastodons, our entire model of the past is wrong. We are a species with amnesia. The Younger Dryas cataclysm, whether caused by an impact or by some other terrestrial process, would have been a great filter. It would have created what some have called the Great Forgetting. A technologically advanced maritime civilization would have been uniquely vulnerable. Their coastal cities would have been destroyed by mega tsunamis and rising seas. Their global trade and communication networks would have collapsed. Their populations would have been decimated, the survivors scattered. Knowledge that had been accumulated over thousands of years, of astronomy, of engineering, of agriculture, would have been lost in a few generations of brutal struggle for survival. In this view, the rise of agriculture and civilization in Mesopotamia, Egypt, and the Indus Valley around 6,000 years ago was not a new invention. It was a recovery, a slow, painful re-emergence from a post-apocalyptic dark age. The megalithic sites that dot the globe with their shared symbols and celestial alignments may be the work of the first post-cataclysm generations, survivors desperately trying to reconstruct and preserve the knowledge of their ancestors. This is a grand and speculative narrative, and it is important to state that it is not supported by mainstream archaeology, but it provides a framework that can account for a wide range of anomalies that the current paradigm struggles to explain. It paints a picture of a human past far deeper, more dramatic, and more cyclical than we have been taught. It suggests that we are not the first, and it places the extinction of the great beasts of the Ice Age not just as a tragedy for the animal kingdom, but as the backdrop for a near-extinction event in our own human story. You are on the shores of Lake Titicaca, the highest navigable lake in the world. The water is a deep, impossible blue, and the air is thin and crystalline. You look across the water towards the mountains of Bolivia, where the ruins of Puma Punku lie scattered. It's here, in this liminal space between scientific evidence and ancient memory, that the threads of our investigation begin to converge. On one hand, you have the hard data, the Younger Dryas black mat, the platinum spike, the nanodiamonds, the evidence of continent-spanning floods, and the sudden, catastrophic extinction of the megafauna. On the other, you have the human story, the flood myths from every corner of the globe, and the sudden appearance of astronomically aligned megalithic architecture built by supposed hunter-gatherers in the immediate aftermath of the cataclysm. For a long time, these two streams of inquiry, mythology and geology, were kept strictly separate. To suggest a link was to invite academic ridicule, but that is beginning to change. A new generation of researchers is starting to ask if it's possible for oral traditions to preserve the memory of real geological events across thousands of years. Studies of Australian Aboriginal myths have shown that they contain accurate descriptions of coastlines that were submerged by rising seas over 7,000 years ago. This proves that high-fidelity cultural memory is possible over vast timescales. So, when we hear hundreds of cultures tell stories of a world-ending flood, of fire from the sky, of an age of giants that was swept away, it becomes harder to dismiss it all as mere fantasy. It begins to look like a data set of its own, a human archive of a planetary trauma. The great mystery is not just what killed the mammoths, but what happened to the people who lived alongside them. The rocks and the ice cores tell one half of the story. The myths and monuments of our ancestors may be telling the other. You're in a canoe, paddling silently through the wetlands of northern Australia. The air is thick, humid, buzzing with insects. An Aboriginal guide points to a rock art gallery on an escarpment overlooking the floodplain. Among the paintings of kangaroos and fish is something else. It has a trunk, large ears, and a high-domed head. It looks for all the world like a mastodon or a related proboscidean, animals that scientists believe died out on this continent over 40,000 years ago. This is the challenging frontier where science and story meet. Can an oral and artistic tradition accurately preserve an eyewitness account of an animal that has been extinct for millennia? Skeptics argue that the painting is a misinterpretation or a depiction of a mythical creature. But the stories that accompany the art are specific. They speak of a time when the sea was much lower, when what is now ocean was a dry, hunting ground. Geologists confirm that this was the reality during the last ice age. Across the world, similar stories persist. The Mi'kmaq people of eastern Canada have stories of Cat, the giant moose, which some have linked to the stag moose, a megafauna species that went extinct at the end of the Pleistocene. In Siberia, the Yukagir people have detailed myths about the mammoth, describing its appearance and behavior with an accuracy that suggests a deep, ancestral familiarity. These are not just charming folktales. They are data. They are the human record, preserved not in stone or ice, but in the most resilient and ancient medium we have, memory. To read them as literal, scientific textbooks is a mistake, but to dismiss them as pure fiction may be an even greater one. They are a chorus of voices from the other side of the cataclysm, a fragmented, dreamlike archive of a world we have forgotten. They speak of a time when giants walked the earth and when our ancestors walked among them, and they hint that the event that severed that world from our own was sudden, violent, and unforgettable. You are in the Fertile Crescent, standing in a field of wild wheat. The sun is warm on your skin. You rub a few grains between your fingers. It was here, in the shadow of the mountains that hold Göbekli Tepe, that the agricultural revolution began, just after the end of the Younger Dryas. For 200,000 years, humans had been hunter-gatherers. Then, in a geological instant, we settled down and began to farm. Why? The conventional answer is that the new, warmer, wetter climate of the Holocene made agriculture possible. But what if it also made it necessary? The hypothesis of a lost civilization offers a different perspective. If there were advanced societies before the cataclysm, they would have possessed a deep knowledge of agriculture. In the chaotic aftermath, with ecosystems in ruin and traditional food sources gone, this knowledge would have been the key to survival. The myths of ancient cultures are filled with stories of this transfer of knowledge. In Egypt, the god Osiris was said to have taught humanity the arts of agriculture. In Mesoamerica, it was Quetzalcoatl, the feathered serpent. In Mesopotamia, the Apkallu, or seven sages, emerged from the sea after the Great Flood to give civilization to mankind. These are the culture-bringer myths, found all over the world. They tell of godlike beings who taught the scattered, traumatized survivors how to farm, how to build, how to track the stars. Could these be the mythologized accounts of the survivors of a lost civilization, sharing their precious world-building knowledge with the less advanced hunter-gatherer populations they encountered. It would explain the sudden, almost miraculous appearance of agricultural know-how in multiple unconnected locations at roughly the same time. The seeds of the plants that would build our world were sown, but perhaps the seeds of knowledge that allowed us to cultivate them were a deliberate gift, an inheritance from the world that was lost. You sit in a university office, surrounded by maps and books. On a screen, you trace the strange global distribution of the culture-bringer myths. From Viracocha in the Andes, who traveled from the shores of Lake Titicaca to teach the arts of civilization, to Oannes in Mesopotamia, a fish-like being who emerged from the Persian Gulf. They almost always arrive by sea. They are almost always described as being pale-skinned and bearded. They almost always arrive in groups of 7 or 9. The 7 sages, the 9 lords of the night. This pattern, repeated in cultures with no known historical contact, is a profound anomaly. If we entertain the idea that these myths are not fantasy, but a distorted memory of real events, then we can begin to treat them like a forensic puzzle. We can trace the supposed paths of these sages, these survivors of a drowned world. Their mythical journeys seem to radiate outwards from key locations: the Sunda Shelf in Southeast Asia, the coasts of the Americas, the Mediterranean basin. These are the very areas that were most dramatically affected by the sea level rise at the end of the Ice Age. The hypothesis suggests that a global maritime civilization devastated by the Younger Dryas cataclysm sent out its surviving members in a desperate last-ditch effort to preserve their knowledge. They traveled the world, seeking out the scattered tribes of hunter-gatherers who had also survived, and they taught them. They taught them agriculture, architecture, astronomy, and law. They became the mythical civilizing heroes, their true human origins eventually forgotten and elevated to the status of gods. This is a story that exists at the far edge of scientific inquiry, a place where the lines between evidence, myth, and speculation become blurred. There is no single piece of archaeological evidence that can prove it true. But the sheer weight of the circumstantial evidence, the shared myths, the shared symbols, the shared architectural and astronomical knowledge presents a compelling and consistent picture. It's a picture of a human story far more ancient and mysterious than we have ever dared to imagine. You return to Murray Springs, Arizona. You kneel once more before the trench wall, before the stark boundary between two worlds. The sun is hot on your back. Your perspective has shifted. When you first saw this thin black line, you saw a geological anomaly, a layer of enriched carbon and exotic metals. Now, you see a story. Below this line is the evidence of a deep and stable past. The bones of mammoths and camels, the stone tools of the Clovis people who hunted them. It was a world that had existed, in one form or another, for hundreds of thousands of years. Above this line is silence. The megafauna are gone. The Clovis people, those master hunters, vanish from the archaeological record, replaced by different cultures with different toolkits. For 1,000 years, the human population of North America seems to have collapsed. This is the human dimension of the extinction. The Younger Dryas cataclysm was not just an ecological event. It was a profound rupture in the human story. If a lost civilization existed, it was annihilated. If it did not, then the hunter-gatherer societies that witnessed the event were traumatized on a scale we can barely comprehend. The survivors were cast into a dark age, a 1,000-year winter in which the world was colder, darker, and emptier. The black mat is the gravestone for that lost world. It is the sediment layer of the Great Fire and the Great Flood. It is the boundary line of the Great Forgetting. When humanity re-emerges on the other side in the warmth of the early Holocene, it is different. We have agriculture. We are building massive, astronomically aligned stone temples. We are telling stories of a golden age that was lost and of the civilizing heroes who brought knowledge back to the world. The line between what happened to the mammoths and what happened to us begins to dissolve. We were not just witnesses to the extinction. We were fellow survivors. You are walking away from the trench at Murray Springs. The shadows are long and the desert air is cooling rapidly. You carry with you the weight of the evidence beneath your feet. The black mat is not a theory. It is a physical reality, a scar left on the body of the earth. The platinum, the nanodiamonds, the melted spherules, these are not myths. They are microscopic facts waiting for an explanation that can account for all of them. This journey began with a single, focused question. What killed the woolly mammoths? We have followed the evidence from the frozen tombs of Siberia to the astronomical temples of the ancient world. We have investigated climate change, human hunters, and a cosmic cataclysm. And what has become clear is that no single answer is sufficient. The truth, as is so often the case in science, likely involves multiple factors. The emerging consensus of a perfect storm of stressors, a changing climate that shrank their habitat, the arrival of a deadly new predator, and perhaps a final catastrophic blow from the sky, seems the most plausible. But this investigation has opened up a second, even deeper mystery, not just about the end of the mammoths, but about the beginning of us. The evidence for a global cataclysm at the Younger Dryas boundary is compelling, and the timeline of that cataclysm aligns perfectly with a profound rupture and reset in the human story. The possibility that there was a sophisticated human civilization in the Ice Age, a civilization that was lost in the same event that killed the megafauna, can no longer be dismissed out of hand. This is not a proven fact. It remains a fringe hypothesis, a ghost story haunting the halls of orthodox archaeology. But it is a hypothesis built on a growing mountain of anomalous evidence, and it reframes the entire mystery. The end of the Ice Age was not just an extinction, it was a planetary reset button. And we are the children of the world that came next, haunted by the faint, dreamlike memories of the world that came before. You are standing on a mountaintop in the Atacama Desert. The air is cold and so clear it feels like a vacuum. Above you, the Milky Way is not a faint smudge, but a blazing river of light, thick with dust lanes and nebulae. This is one of the darkest, driest places on Earth, and it is here that we have built our own great temples to the sky, the Atacama Large Millimeter Array. Dozens of massive radio telescopes turn in unison, listening to the echoes of the Big Bang. It is a humbling experience to stand here at the apex of our technological civilization and to realize that we may have only just relearned something our distant ancestors knew intimately. The builders of Göbekli Tepe, of the Serpent Mound, of Stonehenge, they were all astronomers. They understood the slow, grand cycles of the cosmos with a depth that we are only now beginning to appreciate. Their obsession with the sky was not a quaint spiritual belief. It was a science born from the trauma of survival. The Younger Dryas impact hypothesis, for all its controversy, provides a powerful explanatory framework. It suggests that our planet is not a closed, stable system, but one that is vulnerable to periodic, catastrophic encounters with cosmic debris. The torrid meteor stream, the debris field of a giant comet that broke apart tens of thousands of years ago, is a known and present danger. We pass through it twice a year. Most of the time, we are spared. But the geological and mythological evidence suggests that 12,900 years ago, our luck ran out. If this is true, it changes everything. It means the end of the mammoths was not a gentle fading, but a violent planetary-scale execution. And it means our own history is built on the ruins of a forgotten chapter, a chapter that ended in fire and flood. The ancient skywatchers knew this. They encoded their knowledge in stone and story, a warning that the cosmos is not always benign. Here, under the blazing stars of the Atacama, surrounded by the quiet hum of our most advanced instruments, you can almost hear their whisper across the millennia. Watch the skies. You gaze up at the Atacama sky, a canopy of diamond dust on black velvet. The silence of the desert is profound. You feel a sense of vertigo, not just from the altitude, but from the immense gulf of time that separates you from the events we've been investigating. What really killed the woolly mammoths? After all the evidence, from bones to black mats, from Clovis points to comets, we are left without a single, definitive answer. And perhaps that is the most important lesson. Science is not a book of answers. It is a process of asking better and better questions. The mammoth extinction remains a genuine, active mystery, a cold case that is 13,000 years old. New discoveries continue to revise our understanding. The thawing permafrost of Siberia is yielding perfectly preserved specimens that allow for genetic analysis we couldn't have dreamed of a decade ago. Submersible technology is beginning to allow us to explore the drowned coastlines of the Ice Age world. The debate over the Younger Dryas impact continues to rage in peer-reviewed journals, forcing a new level of rigor on all sides. And this brings us to the most unsettling question of all. Are we a species with amnesia? The narrative of a lost, advanced civilization of the Ice Age, destroyed in a global cataclysm, remains far outside the scientific mainstream. It is a story told in the language of myth, geology, and architectural anomaly, not in the clear prose of archaeological consensus. But it is a story that refuses to go away. It is a possibility that haunts our prehistory, a ghost in the machine of our accepted timeline. Could it be that the same event that wiped out the mammoths also wiped our own collective memory, leaving us to slowly, painfully rediscover the knowledge that we once had? We may never know for certain, but the questions themselves change us. They force a new sense of humility, a recognition that our past may be far grander and more tragic than we have ever believed. You are standing on a beach in Indonesia, looking out at the turquoise water. The sun is setting, painting the sky in shades of orange and violet. Beneath the waves, just a few hundred feet from where you stand, lies a landscape that no human has walked on for 10,000 years. It is the drowned continent of Sunderland, a vast coastal plain that was once the heart of a vibrant Ice Age ecosystem. This is where all the threads of our story come to rest, in the quiet depths of the ocean, the evidence for what ended the Ice Age world, for what killed the mammoths, what shattered human societies, what flooded the coastlines, is all around us. It is in the ice, in the earth, in our myths, and in the megalithic structures our ancestors built. But the final, definitive proof, the ruins of a lost civilization's coastal cities, may lie forever beyond our reach, buried under hundreds of feet of water and millennia of silt. Perhaps we will never know for certain. The past is a foreign country, and its capital city is now underwater. But the investigation itself is what matters. The journey has taught us something profound. It has taught us that extinction is not always a slow, gradual affair. It can be sudden, catastrophic, and driven by a complex interplay of forces. It has taught us that our own story is inextricably linked to the story of the planet, and that we are not immune to the kinds of planetary-scale disasters that have reset the course of life on Earth before. The mammoth's extinction is not just a paleontological curiosity. It is a cautionary tale. It is a mirror in which we can see the reflection of our own precarious present. We too live in a time of unprecedented climate change, of human pressure on ecosystems, and of a growing awareness of the cosmic dangers that surround us. The story of the mammoth's end is a reminder that even the most dominant species can vanish in a geological blink of an eye. The great mystery is not just what happened to them, but what we will choose to do with the knowledge their story gives us. You are back in Siberia. The helicopter that brought you here is a receding speck in the enormous sky, its sound swallowed by a silence that feels ancient and absolute. You're standing on a riverbank where the thawing permafrost has slumped, revealing a cross-section of the past. A local ivory hunter hands you a clump of reddish-brown fur, coarse and thick between your gloved fingers. It's mammoth hair, preserved for 10,000 years. Holding it, the abstract mystery becomes intensely, physically real. This was a living, breathing creature. The scientific quest to understand its end has taken us across the globe. We've read the climate record in the Greenland ice, found the hunter's spear point in the American plains, and traced the faint chemical signature of a cosmic impact across continents. Each theory, climate, overkill, impact, holds a piece of the truth. The emerging scientific picture is of a perfect storm, a cascade of stresses that overwhelmed a species that had survived for 400,000 years. The habitat changed, a new predator arrived, and the planet itself was rocked by a cataclysm of uncertain origin. But the deeper we looked, the more the mystery of the mammoth's extinction became entangled with our own. The evidence of that same cataclysm is written in our oldest myths and carved into our most ancient stones. The story of a great forgetting of a world that was lost. What if the builders of Göbekli Tepe and the singers of the flood myths were trying to tell us something? Not just what happened, but that it could happen again. That our world is fragile, our place in the cosmos not guaranteed. The warning, encoded in star charts and sacred stories, is that planetary stability is not a given. You look out over the vast, empty tundra, a landscape once filled with millions of these magnificent animals. You feel the ghost of their presence. The mammoth's story is a message in a bottle, washed ashore from a drowned world. It is the echo of a forgotten warning. The final, unsettling question isn't just what killed them. It's whether we, in our own turbulent times, are capable of hearing it.